everybody. Thank you very much. Yes, Tata is, it's a different world by itself. And if you take the average distribution of resources across the country, I would say Tata is at the one end of the spectrum. So at the positive end of the spectrum. And it would be interesting for you to know that Tata was actually started by the Tata Trusts. It's a corporate entity. And in 1940s, and later handed over to the Department of Atomic Energy, the government of India. And Tata Trust till today continues to do a lot of things for the country, and that is one organization as a corporate who does more than what is actually known in the entire world. Just to show you the Land Rover Jaguar is owned at the moment by Tata Trust. Okay, so a lot of things all over the world are owned by Tata Trust, and they do a lot of stuff. But TMC, Tata Memorial Center, is an umbrella organization of a number of organizations. I'll come to that later on. But the nidus was set at Tata Memorial Hospital in Bombay, previously Bombay, now Mumbai. And it has been a pioneer in a lot of senses in our organization, and a lot of people want to work there, including myself, if at all. So if I am in Mumbai, I don't want to work anywhere else apart from Tata Memorial Center. All right, so let me show you the other end of the spectrum as to what is possible in digital pathology. This is the general outline where I'll show you what is happening in pathology in general and the AI and digital pathology, what it promises us, what is the government doing, what we are doing, and what we are planning for the future. As a general statement, the previous speakers have already said very well the distribution of the resources in the developing world, and it is true for India as well. And what is fascinating is that the level, it is not a uniformly bad scenario everywhere. There are areas which are very well staffed, areas which are very poorly staffed. And most of these organizations exist side by side. They simply are across the road. So for example, you have Tata Hospital over in this side of the road, you have KEM Hospital, another municipal hospital across the road, which would not have basic immunohistochemistry facilities and they would refer all the services to us. So there's a lot of disparity across the country. Even in a city like Mumbai, there is a lot of disparity, but there is a lot of possibilities that are there, and we are trying to take everybody together as much as possible. Now, for a population of 1.3 billion, and it's still growing and is looking to surpass China in some time, we have a relatively small population of what we would call as pathologists and oncopathologists. I focus on oncopathologists because it is a cancer center and we are talking of cancer in general. The practice at the moment is largely driven by economics. So patients still pay out of their pocket. Insurance practice is not the norm. Less than 10% of the entire practice happens through the pockets of the patients. And therefore, there is a lot of, we have to accommodate for a lot of patients. And we have some differential pricing systems so that we can take care of patients who can pay as well as patients who cannot pay. And I'm quite proud to say, nobody who reaches Tata Hospital gets out of Tata Hospital without getting some sort of treatment that is to be planned for them. The quality assurances across the country are not very well established. There are national organizations, there is NABL, there are the ECAS programs, etc. Some hospitals also participate in the UK ECAS and the CAP ECAS programs. We have our own ECAS program as a part of what we call as the National Cancer Grid, and we offer it free of cost to all the hospitals across the country. And there are many internal validation programs that are ongoing, but again, I would say that not more than 10 or 20% of the hospitals or the laboratories take part in these kind of programs, and the basic pathology services are quite varied. What does digital pathology mean to us? It means a lot of things. the basic discussion always rotates around scanners and the algorithms, etc. But there are so many other factors which are not discussed very well. And for us, we are fortunate now that India is called the digital back end of the world, and we have a lot of outsourcing things happening from the Indian continent. And so we have a significant amount of technological availability, and we are kind of trying to harvest, use all of these advances in the digital and the telecom industry and the academic industry, and use them to bring in digital pathology into the country. One of the major factors that is going to affect is obviously the price. What if at all do we manage to get in the digital pathology across the country, which we are hoping to do, is there's a lot of things that can happen. It can facilitate so many other programs simultaneously without additional. So the digital pathology has very wide-reaching effects on the entire country, and it is not simply the AI algorithms or simply the pathology program that it will affect. It will affect a lot of other things, and it will have a far-reaching effect, and it is in the best interest that we do it in some form. So let us look at the main factors that are affecting the AI and the digital pathology push in India. And we have, this is based on my personal experiences and this thing as to what are the different factors which are affecting, and my conversations with different startup companies, digital pathology companies, that's also. So currently, most of the scanners that are available are basically closed systems. They are available in some of the larger institutes like Tata Hospital, Tata Memorial, Tata Medical Center, Calcutta, something in AIIMS, PGI. But they are largely standalone systems they are basically scanners which can scan an image and store it in some computer. They don't go beyond that, and everything else is the viewer, etc., gets packaged with them by the company. It's a closed system, very little interoperability. There is a company which has made its own independent digital slide management system. Sector doesn't have a presence in India. However, there is a company called as IRA Matrix, or what was also previously known as Aditya Imaging Technology. They have their own image management system. Interestingly, they started off from the pharma industry and veterinary pathology, and now are making their inroads into the clinical diagnostic systems. So this is the spectrum of the scanners that are available in India. So we have a lot of spectrum available. So we have the most expensive ones. A lakh rupees is roughly 1,000 pounds. So 15 lakh would be around 15,000 pounds. Some of these scanners are made in India by Indian companies. Some of these, like the Morphil and Microscan, are basically Indian companies. Morphil actually started off as an AI company, and they realized that the technology doesn't exist, a cheap technology for scanning doesn't exist, and they first diverted their attention towards developing a scanner which is low cost. And now they have a scanner which is relatively low cost, 15,000 pounds. There's an entire spectrum of available from across the world, which are also available in India. India is a country of what we call hacks. The Indian word for it is jugaad. Okay, it's a jugadu country. We can reverse engineer anything and everything. So some of these systems have been designed to work with smartphones, and they use traditional microscopes and stuff like that. And some of them can be available for as cheap as $300 and $500 pounds, for that matter. Of course, these are not high throughput systems. These are not the high-end system that we are talking about, but they do solve certain specific problems that you might have. Say for a low income, you simply want some image to be transferred. It was very well enough. And some of them have been quite significant. They use the advantage that most people already have a smartphone with them, even in India. Even the most poor person would have a smartphone with them, because we get a smartphone for some 1,000 rupees, that is around 10 pounds. And so that kind of a thing is possible. The government is coming out very well in support of AI. So this is the document from June 2018, wherein a new think tank, which replaced the Planning Commission, the Niti Aayog. So Niti actually stands for the word as means policy, but the Niti is also an acronym for National Institute for Transforming India. And they are no longer government bureaucrats. They are people from the industry and the academia who are planning, offering suggestions to the government as to what needs to be done. It has set a push towards giving AI in a lot of fields, including agriculture and education and things like that. But one of the thrusts that we are working on with them is in the healthcare sector. So we also have one of the largest startup ecosystems in the country. So this is official government statistics. And unfortunately, the pathology startups in this area are quite few. Now, some of these words you have already heard of, names, ECDP, AI Indra. Now, one of the problems that we face, which I feel is the real problem, is why we are not probably able to use all of it together, is that all of these systems are not very popular, or people don't know about it. The information dissemination is not adequate. The various players work quite much in silos. So, for example, we have a gentleman from here from IIT Mandi, and this is the first time I'm meeting him here. From my country, but I'm meeting him here for the first time. So this kind of things quite are there, because it's a huge country, a lot of things happening, and we have many low-cost systems that have been developed. We have for Pap screening and for cervical cancer screening, we have a lot of things that have been developed and being published as well as, but most people would not be aware. So the dissemination of information is, I think, is one of the major factors where we are not able to come together into the, to channel our efforts together. So as far as if you look at the matrix again, the startup industry, the government setup, the technology availability is not a problem. I think what the problem is the user demand, the pathologist demand, the pathologist awareness, and the academic interest in this area. So I think if these two areas can be taken care of, I think we have enough thing that can be done. So the corporate industry is very much, in India at least, is very much supportive. And we have many examples, not just the Tata Trust, but we have many other examples where they have come forth and established entire systems. The Aadhaar card or the biometric system has been established for practically no cost by a corporate system, and it's an extremely effective area where we can work together. So what is stopping the Indian pathologist? Apart from lack of initiative, I think they are still confused as to what they want. Okay, so they want everything. They want it to be fast, they want it to be great images, they want it to be cheap. But I think that is an area which is, the finding the impossible utopia, or the finding the mix of right amount of everything is very difficult. What they don't realize most often is that we cannot control more than two. If you get something that is cheap and great, I think speed will always be a problem. If the speed or quality is great, cost is always going to be a problem. So the discussions regarding these are not happening as much frequently, and we are still debating as to what we want, what I am willing to compromise on, what I am not willing to compromise on. On all of these aspects are more relevant to it. And I still want to wait for, just to see how much of this is really a bubble which will burst very soon, and how much of it really remains behind the hype, will settle down in some time, and then I want to see. We have come a long way as far as digital pathology is concerned, and the evolution of digital pathology from what it was a decade ago. But I think this is still the beginning of the journey, and a lot of things are still to happen, and we are still not able to decide between what we need and what we want and what we desire. And interestingly, because of the variability across the entire country, a lot of these things are different for different people. So let me give you an example. So on your left is a typical 5-course or 7-course meal that you would have in Britain or US. You have fixed things coming in fixed times, one after the other, fixed order. You can't ask for it again, right? And on the right-hand side, you have the Indian thali. I can eat anything in the way I want. I want everything together at the same time. Unfortunately, since most of these technologies have been developed in the Western world, the mentality and the understanding of the Indian consumer is not very well understood. I want everything, I want to choose what I want to eat. You don't ask, show me what I should eat. That's the point. Sometimes if the plate is small, I still keep my options outside the plate. So a lot of things, there's a difference in the consumer mentality, the culture. There's a lot of difference in how we do business. And therefore, I think until these differences are sorted, there is always going to be a relative. It's not that the government cannot afford all of these scanners. Yes, we can afford all of these scanners. At least the government can afford to buy and put them in the big hospitals. But just that my mentality and my culture tells me something else, while you are telling me something else. So there's a lot of difference at that level. So I think the biggest problem is that the user demand is low. Pathologists are not involved in the process. I think it is same quite over here also, but at the moment it's still better than what it would be in India. It still escalates cost for the patient, right? I mean, you are adding an additional level. It's not like radiology where you are taking out a certain amount of things and putting it a new thing. You are still making your slides, you're still scanning them, you're still storing them, you're creating digital storage, and 2 GBs of data per slide is a huge amount of data to be stored, and where each patient would have at least 50 slides for, say, a surgical resection. Another thing that is interesting is that the current AI tools that are there are not trained on Indian data, right? I mean, this is a problem that most of the people I speak with, the moment they try to validate it on the Indian patients, it doesn't work very well. And many people who have previously worked outside India, now working in India, they realize there is a lot of difference in the images that we get from India as well as from the outside. And that's true from Tata Hospital and for what they have worked with before. So there's a lot of difference in the patient biology, patient culture, patient other factors, economic factors that need to be taken care of. And as a result, the discussion at the moment is very preliminary. It is still revolving around scanners and not really going ahead. So we are still debating about low-cost scanners and stuff like that, but what we need is a lot of things, an entire process to change. So a lot of these things have to happen. We need digitization, not necessarily only by scanners, but by any means or whatever means possible. And then development of India-specific tools. And finally, the acceptance by the user as to be taken to try to at least validate them in a clinical practice. So this is what we are doing at Tata Memorial Center. So let me show you what is our workload. So this is only Bombay. So we do around 70,000 histopathology, and that leads to around 500,000 slides, 500,000 slides to be generated annually with a 10% year-on-year increase. We generate around half a petabyte of data. And that too we would have to annually, and then we would expect to store it for at least 10 years if we have to go by the national guidelines. And if, as an academician, I would not like to throw them at all. So, the magnitude of the task for a single center by itself in Mumbai alone is such huge, and we are actually doing it. So we have pushed for it, and we are trying to digitize the entire system, our entire pathology workload, which should happen in say a few years. We have had some experience with machine learning methods using data itself, and this is one of the tools that we have developed in-house, which uses the age and gender and the IHC. So how do I? Yeah, so age, gender, and the IHC profile, and it gives you age and demographic specific Bayesian probability of it being a particular cancer based on the IHC pattern. We have worked on these kind of works. All of these are things in various stages of publication, where Heinz grading of cancer of esthesioneuroblastoma. We have tried to develop it, make it much more objective. We have been able to identify papillary thyroid carcinomas which will metastasize, have a distant metastasis versus ones which will not metastasize, and all of this has been done by us as a pathologist, basic machine learning techniques, and we have been able to reach very high AUCs. This is some of the work that we have been doing with IIT Bombay, so we have a very strong group at IIT Bombay, and hopefully we'll collaborate more with other IITs also, wherein we are trying to predict the BRAF mutation from the H&E image, and we are moving towards not simply the black box approach, but also trying to back-propagate onto the image as to which is the area which it is identifying as the area responsible, and then train pathologists to probably identify those things. So in this particular approach, we had a threefold validation, and the accuracy was quite high, 94-95%. Similar work done by Amit Sethi, my main collaborator, wherein he has done work on prostate cancer and predicting, and we are looking to validate this data with this particular algorithm on the Indian data set. So he generates a heat map of the area which will predict, and it generates a score as to what is the probability that this patient would relapse further. He has also worked on areas of intratumoral heterogeneity and trying to predict the HER2 positiveness and the triple negativeness score of breast cancer patients using simple H&E images. And of course, he has also done quantification of IHCs. We also have these algorithms on color normalization that have been developed. Now, we are trying to put all of this together into we have also worked on a lot of radiology work previously. Radiology efforts are much more prominent, and these are some of the papers that we had published. Last year, we did stand third in the prediction of survival using the radiology glioblastoma images. So there's a lot of collaborative work happening in different areas, different stages of funding, different stages of approval, different stages of actual work being happening. What we realized while doing all of this is that all of this data actually comes from TCGA or some other European or American data set, and then the representation of the Indian population is not very well. And then at the end of the day, I want something that works on the Indian patient. Therefore, and the lack of annotated data, it is the single step which is the highest rate limiting step is the availability of quality annotated data. So this is what we are trying to do at TMC. We are creating an image biobank of Indian patients from across the country, wherein we are taking radiology and pathology images and linking them with clinical and genomic data that has been curated outside of the scope of this, and then try to use this in different AI projects, and initially do it in a retrospective manner and then validate it further in clinical trials. This is the kind of image data that we already have, and we are trying to collate it into an interlinked database, and this would be available to almost anybody across the world who wants to work on Indian patients. So let's say in a year or year and a half time, we should have a significant amount of data set ready. We are trying to merge radiology and pathology data together, and we are trying to address these problems wherein we're trying to train radiology algorithms based using pathology images to detect a lot of anomalies, as well as predicting histology on radiology. You see, in a distant metastatic setting, we won't really biopsy every tumor. So if it's a wildly metastatic tumor, for example, we are going to biopsy only one particular area and then do molecular testing on it, or do histopathology on it, or anything else that we want to do. But the intratumoral heterogeneity is so wide that there might be a tumor clone in some part of the body which would be HER2 negative, while the biopsy that you have done is HER2 positive. And therefore, there is this, we're trying to bridge this gap wherein we use histopathology images and IHC images to train a radiology model which can look at the radiology images and tell us whether this area would be HER2 positive or triple negative and stuff like that. So digital pathology not only means digital images, but it also means digital data for us. Okay, so we traditionally pathology report has been a free text report. People type it out in either a word-like format or some other free text format, and then it goes as a report. And then extracting data out of it either has to be done manually or some natural language processing tools have to be applied, again with variable level of accuracy. So we have now changed the entire way we do the reporting. We have this kind of a objective reporting system. It's a level 6 synoptic reporting system where the pathologist only enters the data points. It only makes the selection across the board. The system generates the report in the language that we want. And therefore we can generate multiple reports, synoptic reports, detailed reports. We can merge the gross and microscopy together or whichever way we want. It adds a lot of background SNOMED coding, SNOMED and ICD coding, a lot of things happening at that level. These are some of our collaborators. There is a longer list. These are the main collaborators with which we have very active work happening. We are developing some image analysis tools with IRA Matrix. Okay, so let me tell you what TMC is. So TMH started as in Bombay in 1942. Today we are spread out across the country. These are the different hospitals and the centers that we have across the country. So in Mumbai itself, we have 3 centers, TMH, ACTRIC, and this CCE is a Center for Cancer Epidemiology. So it's totally dedicated to cancer epidemiology. Others are hospital-based centers. We have also something called as a National Cancer Grid in order to harmonize the treatment and management guidelines across the country so that patients don't have to travel too much out of the, to either to Tata Hospital or some other center. And we have around 168 centers now. 2 years back, there were around 25 centers. Now we have 168 centers on board where we try to harmonize the treatment, the pathology, as well as the radiology and the other management guidelines that are there. So we have our own, so there is a website, NCG, if you put the National Cancer Grid, there's a website you can reach. We have some India-specific guidelines that are there on that. And we hope to actually take the advantage of such a wide network of hospitals that we have brought under a single roof and extend the AI tools that we develop in-house. These are some of my major collaborators. Amit Sethi, Dr. Sangeeta Desai is the head of my department. Dr. Sudeep Gupta, Dr. Rajendra Badwe, and Dr. Pramesh are the directors of the hospital. Rajiv is one of my colleagues in pathology. He works very well. He looks after the acquisition of the entire digital pathology system. And Abhishek is the radiologist with whom I work very closely. Thank you very much. Sure.
So Ian Cree from IARC, WHO. Just a quick question about the synoptic reporting, really. Are you able to use and are you using the ICCR reporting system?
Yes.
Great. Because
that's the current standard.
That's the international standard.
That's the RCPath CAP and the Australian thing coming together.
One of the things that is very valuable,
yes,
certainly for the WHO classification of tumours, which I run,
yes,
is the ability to look at data that is similar and collected in a similar way across multiple countries.
Yes.
And the fact you're doing that obviously is very helpful.
Yes, so we are using that ICCR guidelines as well.
One more question.
So I like the fact that you showed the whole spectrum of digital pathologies because, among various academics, and I speak on behalf of the academic community, that we mainly focus on either the AI algorithms or at best, the proverbial cloud computing, basically. So I like one point about data storage. So we often neglect the fact that you have such large data, and storage could be an issue. So would sort of going back to look at, say, something like image compression algorithms or data compression algorithm in general could be one of the areas where that could be one of the important things to contribute.
Yes, definitely. So the compression algorithms is one of the areas that Amit and some other people are still working on, as to which one is to be used actually for, there's so many of them. Even if we go for a lossless algorithm, lossless optimization, there would still be some amount of, and what is the real benefit out of it versus, and then we are still trying to channelize as to how much of those images will compress, how much we keep in the non-compressed format, and to what, and so the different things are being worked out. And a lot of people involved in that work, yeah. Sorry? It's an open area. So if you have some ideas, we'll be very happy to incorporate those.
Thanks again to Dr.
Sure.
Rane for an excellent talk.